Okay, so before we jump into our first remote learning lesson, I kind of wanted to give you guys an overview slash outline of what the next few weeks are going to look like for remote learning, just so that way you have an idea and you're prepared. So I talked with the AP Calc and AP Stats teachers, and based off of their feedback, kind of went from there on what type of stuff did they think it would be best for you guys for next year. So the big thing was they agreed that reviewing some algebraic concepts, specifically log and exponent rules, to be more comfortable and do more practice on that, so that way next year you guys are more efficient on converting between logs and exponentials on a more regular basis. Also, trig identities, sorry, they are not going away next year. So just be sure that next week we are going to be working on trig identities and working on solving and stuff like that. And then I'm hoping on week 3 to throw some new material at you guys and do some intro to calculus. So if you're not taking calc next year, that's okay. It's good intro because you'll probably take a calc course in college. And then a heads up, we're not going to be doing any more 3D. Depending on how the semester goes, we'll see from there. But there is not going to be a 3D test or anything like that. So just so you know. So with that being said, also, before spring break, we were gonna, hopefully, you were gonna turn in test corrections to me so I could have graded those over break. And so, seeing as we didn't have school that Friday, I am still wanting to take those Unit 6 test corrections just because we didn't have school. That's not fair to you guys. So if you could email me pictures of your work, meaning your test corrections and also your extra problems from your textbook, that would be fantastic. And I want those by the end of this week, so that would be this Friday for 3. All right. So we did exponentials and logs at the beginning of the semester. Hopefully you remember that the big relationship between the two is that they're inverses of each other. So the reason why I have a coordinate plane here, just kind of to think, if we had the function y equals 2 to the x, so we know if I plug in 0 for x, 2 to the 0 is 1, 2, and then up to 4, and then 5, 6, 7, 8, up to 8. So this is the function y equals 2 to the x. And then we know it has that horizontal asymptote. But let's say we have y equals log base 2 of x. So the inverse, well, 1 is 0, 2 is 1, 4 is 2, 3. All right, so then it would look something like this. And then instead of it being that does not look good. Instead of it being a horizontal asymptote, it's that vertical asymptote. So why I know they're inverses is if I were to graph the line y equals x, which is what I'm doing here in this like bluish color, if we look at this, this here shows that they're inverses, right? Meaning that the coordinates here are 0, 1, and then the coordinates here are 1, 0. So that just shows that they're inverses, and just knowing this fact, it helps us remember with the exponent and log rules that they're just like reversed of each other, okay? So a quick, and I am not going to do all of these examples, but a quick, just good to remember exponent rules. We got multiplication, division, power, all this fun stuff. So why I want to quickly review this, for instance, obviously 8 to the power 0 is 1. This is just a good habit to have. So for instance, if we had something here where it was 4x to the 5th y over 16x y to the 4th to the power of 3, you could go about reducing this and simplifying it in a multitude of ways. You could do the, power of a fraction rule and distribute, but that is a lot of work. So what we usually do is think of PEMDAS, simplify your inside first. So here, I look at the fraction 4/16, I know that's going to be 1/4. And then I am going to look, well then if we have the quotient, right, if they have the same base, so the division rule, the quotient rule, you subtract the exponents. So here we have x to the 5th and x to the 1st. That's x to the 4th. And here y to the 1st, y to the 4th. Well, that's y to the negative 3rd. So then you should know when it's negative exponents, it goes in the denominator. So y to the 3rd is here, all to the power of 3. Well, looking at this, now this is a lot easier to distribute to. So if I do that, I get 1 to the 3rd, x to the 12th, so we're multiplying, 4 to the 3rd, y to the 9th. Well, 1 to the 3rd is 1, x to the 12th, 64, y to the 9th. That would be the simplified answer, all right? Like I said, I don't think I need to go through all of these. That was kind of the best one to go over and talk about when we review this, okay? So the ones that I think we had more difficulty, though, were the log rules. So if I were to go back, and I'll upload these notes as a PDF like I normally do and not just the video. So that way you can go back and look at these tables that I'm referring to. So if you look at the exponent rules with multiplication, right? If the bases are the same and they're multiplying, we add the exponents. Well, since it's inverses, again, if they have the same base, it means whatever we're multiplying, it turns into we're adding logarithms, okay? So I think that kind of helps in remembering that if you know your exponent rules really well, then knowing that your log rules are the flip of that, okay? I know we had some confusion over some of these ones, I remember. So like an example on this, and I know we were like, why would we do this? Well, when we get to solving, which is going to be the next video I have posted, we want to find what x is, right? So usually we have stuff on both sides, blah, blah, blah. But if we had 6 to the x of like 12, well, if I do log base 6 here, these two cancel, so then I get x equals, and then obviously we do stuff to that side. But the whole intent of knowing these rules here at the end is so we know how to isolate things to get on their own in order to solve equations, okay? Which you guys intuitively know how to do that. It's just looking at the rules. I know it's a little weird. All right, so expanding logarithms, okay? So remembering to do that, expanding means we're taking it from a single logarithm and making it multiple. So here I see that they're dividing. So that's going to be the first thing, is dividing means subtraction. And the bases are going to stay the same. Then if you remember the power rule, these turn into coefficients. So it's 2 log base 7x minus, whoops, not 2, that was a 4. 2 log base 7y. And there you go. Okay? All right. So let's look at, here, we'll look at this one and do this one together. So if I look here, again, this is all multiplying. So multiplying means we're going to add. And the reason why I kind of broke this one up this way is I want to get rid of this cube root. And remember, the cube root of something means the same as raising it to a power of 1/3, okay? So we have log base 3z plus 1/3 log base 3x times y. So it would be log base 3z plus 1/3 log base 3x plus 1/3 log base 3y. So they are both under that 1/3. So I would expect that you would simplify it that way, okay? So if you want to try these next two really quick, so I'm going to be like Dora Explorer. Are you trying? Are you pausing the video? All right. Hopefully you pause the video and then come back and check the answers really quick. So I'm going to just write them out really quick. Whoops. I keep making little, not typos, but writing it out weird. All right. 5 squared, 3 log base. See? Oh my gosh, did it again. All right. So there's that answer. And then this one here. All right. So hopefully these examples ring a bell and that you feel confident on expanding logarithms. All right. So then condensing. Condensing is on the flip side. And condensing, I think, is more important than expanding. I mean, it's good practice to do both because you get more comfortable with the rules. But we use this for solving, right? Like, this is why we know these log properties in order to solve functions. So if I look at this here, since they have the same base, that means we can combine them. They are adding, so that means they are going to be multiplying. Before I do that though, I'm going to bring these powers back. So it's log base 5 x squared, log base 5 y to the 12th. So then your final answer is x squared times y to the 12th. Okay? All right, so let's do one more. I'm going to jump to this one. So again, it's kind of like PEMDAS, right? So PEMDAS means we got to do parentheses. Well, there's no parentheses, but exponents first. So that's why I'm bringing these powers back, then doing your multiplication and division. Whereas here it's like reverse PEMDAS, right? Like we separate it with subtraction and then we brought the powers down. So that's just something to kind of think about, is when we're condensing, we are following the powers in the sense of, I'm going to do exponents first here, and then I worry about setting up the division here because of subtraction, okay? So again, if you want to pause the video so you can do this quick practice really quick and double check your work. All right, hopefully you paused it. If not, I'm not going to know. It's all honor system here. And then 5 to the 4th, so I bring the 4th back. And then this would probably be something where if it was like on an SAT or something, you would multiply it out. And I got, big old number. All right, there's that one. And then this one here. And remember, this dividing by 2 means 1/2. And then if it's a power, if it's 6 to the 1/2, that means the square root of 6. And then here, 5, square root 6 times 11. So then that would be log base 2, 5, square root 66. Okay? All right. So then another one, this one I was told specifically is super important. So rewriting each equation into exponential form. So we can use the log properties or thinking about it, kind of reasoning out. So if you think back to what logs are inverses of exponents, meaning if I do one of these, like an example, log base, let's do 3 of 8, or not 3, 2 of 8 equals something. Well, that something is the exponent, meaning 2 to what power is going to give me 8? And that's where that 3 was coming from, right? 2 to the 3rd gives me 8. So it equals 3. This is why we use logs to solve exponential functions. So if we look here, it's just practicing, how do I rewrite this into exponential form? So your base of your log is always the base of your exponential function. So x. Then it equals the exponent y, and then 191. So x to the y equals 191. So if I do this here, 5 to the negative 2nd equals n. 5 to the 19th equals x. N to the negative 6 equals m. Okay, so that's how we rewrite into exponential form. So then on the flip side, we are going to take it from exponential form and put it into log form. Again, the base stays the same. So the base here is x. So log base x. This time it equals the exponent. So 178 goes into that weird, I don't remember what we called it, spot. All right. So this would be log base 19 of x equals negative 19. Log base x of z equals y. And then log base b of 154 equals a. Okay? So how maybe you could think about it, it's a log, a base, a value equals exponent. All right? So that is the end of the first video lesson here. There is a Schoology assignment that practices your log rules, so condensing and expanding.